Good afternoon, everyone. Here I'm basically going to talk about the activities that we are into in the Chaser project, looking at the pest constraints on cruciferous crops in the study transects, especially Taita, Taveta, and Kilimanjaro, where these crops are a day-to-day need for the smallholder farmers. There was one interesting question from one of the participants on why we selected this crop. Tino basically mentioned that maize, ugali, without ugali the meal doesn't get complete, and without sukuma also the meal doesn't get complete in East Africa. And at one point I came to know the meaning of sukuma. It is push the weak. For a smallholder farmer or for a poor East African citizen, it is basically to push the weak. What he gets easily is sukuma wiki, and so that's how this crop plays a key role for the stakeholders in the transects of Taita and Kilimanjaro. The crucifers are infested by several pests in the transects, and of which the diamondback moth has been a major problem for their productivity. Why a major problem? Because these pests are highly resistant to pesticide sprays. Almost any kind of pesticide that is sprayed doesn't works effectively against the DBM. In this regard, ICIPE had some prior experience in working with this pest. This pest is not native to East Africa. It is an invasive pest, and so the indigenous natural enemy fauna were not able to control this pest very effectively. And in this regard, in an earlier BMZ funded project, ICIPE identified two potential natural enemies, one from Taiwan, that is Diadygma semiclosum, and then another one from South Africa, Coticia vestalis, and we released them in the cruciferous ecosystems in Kenya. Of which one of the parasitoid which you see on the top, Diadygma semiclosum, is suited for the highlands. As it is indicated in the figure, it is suited for the highlands, while the other parasitoid, Coticia vestalis, is suited for the lowlands. So there established a sort of a ecological balance between the pest DBM and also the highland parasitoid Diadygma semiclosum and the lowland parasitoid Coticia vestalis. And interestingly enough, Taita Taveta was one of the pioneering sites where we released these parasitoids, especially Diadygma semiclosum, was released first in Taita Taveta, and then afterwards it was released throughout Kenya. And in the same way, in Tanzania as well, we released Diadygma semiclosum, and in Kenya we also released the Coticia blutili. The economic benefits of the release was quite significant. Earlier, farmers used to extensively spray against the cruciferous, the Diadygma, against diamondback moths and crucifers, almost like 13 sprays for a season, and this reduced to around 2 sprays after the release of the parasitoids. The economic benefits was worked out to be around 24:1 for the investment on research. But now our objective in the Chaser program was to go back again to these areas where the parasitoids were released and to visualize the population dynamics of the pest and the natural enemies and then to understand whether there is a possibility of asynchrony developing between the DBM and its parasitoids. So in this regard, we had a two-pronged approach for this. One is direct field observation studies, and also the other one was lab studies. My initial part of the talk will be basically discussing on the field activities, and later on I'll move into the lab activities, what we have been doing. In the case of the field activities, on the two transects of Mount Kilimanjaro and Taita Hills, we basically classified the region into 3 altitudinal zones, that is low altitude zones, mid altitude zone, and high altitude zones. And we identified 23 farmers across these transects who are regularly cultivating crucifers. And in these farmer fields, we've been collecting the biodiversity data on the pest and its natural enemies for more than 18 months now, and we hope to complete a full year of observations. And apart from the pest and the natural diversity, we are also looking at the wild crucifer diversity around these cruciferous ecosystems, because from my earlier work, it was evident that the presence of the wild crucifers helped in the perpetuation of the natural enemies and also helped in the control of the pests. To have a better understanding of the weather data, we established automatic weather stations, as Tino and Dr. Bridget already mentioned, on these transects, and to support the information from the automatic weather stations, data loggers were also placed in individual fields, and regularly these data loggers provided information on the temperature and the relative humidity existing in that location. So, based on our field observations, what we observed is the key pest, that is diamondback moth, was a problem mainly in the high altitude zones of Taita Taveta and also the Kilimanjaro. But in Taita Taveta, it was also a problem in mid altitudes and occasionally even in the low altitude zones. Another thing we also observed, which also confirmed our previous findings, is during the long rain seasons and also during the cold dry seasons, the dynamics of the diamondback moth goes down. And this was the observation that we got from the field. As we look for diamondback moths, we also look for other pests that's damaging crucifers, because there was increasingly a claim that after the DBM was managed, the secondary pests which were of not of much significance has gained importance, and we also wanted to look at this. And then in that case, we found that among the different other crops, the different other pests that were infesting crucifers, the aphids was a key problem across the altitudinal zones, and a typical change in the diversity of these aphids was seen across the altitudes. Like in the low altitude, the species like Mysis persicae was more predominant or was frequently seen, but as we move up the altitude, the species that were seen on crucifers were mostly Brevigorean brassicae. Apart from aphids and DBM, the other important pest that was also coming into prominence from our surveys was Thrips tabaci, which was earlier known only to be a key pest on onions, but reports were also there on crucifers, but then not to such an extent. But nowadays it is more frequently seen as a key pest on the crucifers, as you see from this graph, especially in the Kilimanjaro low altitudinal zones. Now, to understand the efficacy of the parasitoids which we released, and also the efficacy of the indigenous parasitoids, we looked at the parasitism percentage of different parasitoids across the transects. And what we observed is Diadema semiclosum was the key parasitoid both in the high altitudes and also in the mid altitude zones, while Cotesia vestalis, which was initially released as a low altitude parasitoid, was effective in the low. But surprisingly enough, Cotesia vestalis was also observed in the high altitudes and the mid altitude zones of Kilimanjaro and also in the Taita Hills. This was a bit surprising to us because we were not expecting this parasitoid to move up, and this also gives an indication that there is some sort of a interaction with the climate that is making this parasitoid also to move up the altitude. And in terms of the diversity or the richness of the parasitoids, Kilimanjaro Hills had a higher richness as compared to the Taita Hills. This was also proved from our biodiversity analysis that we did, where the diversity and species richness of the parasitoids were more in Kilimanjaro transects as compared to the Taita Taveta transects. Now, our observation on the wild crucifers revealed that the diversity of wild crucifers are more in case of Kilimanjaro, where we have almost like 6 wild cruciferous species in the mid and high altitude zones, while in Taita Taveta hills the diversity of wild crucifers was much less as compared to Kilimanjaro. In these wild crucifers, we frequently observed the diamondback moth and the parasitoids, and we believe that this is a sort of a green bridge for perpetuating natural enemies for control of the cruciferous pests in these transects. So, some conclusions from our field studies so far are increasing the ecological complexity of cruciferous ecosystems, including diverse wild crucifers, could promote parasitoid efficiency as observed in Kilimanjaro as compared to Taita Taveta. And there is increased importance of aphids and thrips as key pests, which needs to be managed, because what happens normally is when a secondary pest is not managed, the farmers resort back to parasitoid sprays, and a parasitoid spray actually makes because the resistant nature, DBM again comes up as a key pest. So it is absolutely necessary that integrated pest management strategies need to be promoted for other secondary pests so that the balance is still maintained. And from our field collected weather data sets, what we did is, or what we accomplished now is, we have extrapolated from the data loggers the data, and we have established data layers for the transects and both in Taita and Kilimanjaro, which defines the change in temperature and also in the relative humidity. And the ongoing work includes establishing a relationship between the field collected information and the weather data sets to come up with models which can predict the population dynamics of these pests in relation to climatic variables. This was the field study, which we have completed to some extent, and there is still ongoing work. And then in case of the lab studies, what we are trying to do is, as Dr. Samira indicated, we are trying to understand the ecophysiological response of these pests in response to changes in temperatures, where life table experiments are run and life table data sets are collected for the DBM and also the parasitoids. And for example, for the DBM, we have completed the life table experiments at 10, 15, 20, 25, and 30 and 35 degrees centigrade. And for the parasitoids, we have almost the 10 degrees and 15 degrees to be completed before we have a full data set for the parasitoid as well. These are the data sets that are generated for the life table, and we use this insect life cycle modeling software developed by our partners in International Potato Center for establishing phenology models based on this ecophysiological response of the pests. For an example, this is a phenology model of the development rate of DBM in response to changes in temperature, and such functions are obtained for several other parameters like development time, mortality, adult longevity, total and relative ovipositions. Now, once we have this phenology model, these phenology models are run on the extrapolated temperature layers that we have generated for the transects, namely Taita and Kilimanjaro, using the field collected weather informations. And then we have come up with predictions for the establishment, for the generation index and for the survival index of these pests in the transect. As you may see here in the Mount Kilimanjaro, it is clear that the higher altitude zones are more suitable for the establishment of diamondback moth as compared to the lower altitude zones in the current scenario. But in a predicted 2055 scenario, where the temperature data sets were utilized from one of our partners in York University, who have downscaled the regional climatic models, and the data sets for the study areas are available in Africa. And this data was used for predicting the future scenario in 2055. And what we observe is the problem of DBM is going to be much more concentrated in the higher altitudes, while it is going to decrease in the lower altitudes. The same way, the same sort of situation was observed in Taita Hills as well, where in the lower altitudes the problem is going to go down a bit, but then in higher altitudes the intensity of DBM is going to go up. Now, once the similar data sets for the parasitoids are also available, then it will be easy for us to establish where there will be likelihoods of asynchrony, because that's where the area where we consider that are at high risk of DBM outbreaks, where management strategies needs to be promoted very urgently. Some conclusions from the life table lab studies and work in progress. Here, the increasing intensity of D-beam in high altitudes of Taita and Kilimanjaro is expected with climate change. And once the life table data sets for the parasitoids are available, we will be able to establish asynchronous or synchronies between the pest and the natural enemies and identify areas at risk of D-beam outbreaks. And the other thing is we have a prediction based on a lab, and we are trying to do a prediction based on the field observations directly as well. So now there is a need to compare both the lab and the field predictions, how they go in together and things like that. Another advantage with the lab generated phenology model is actually this phenology model can be run on any temperature or weather data layer anywhere. Like for example, when we had the steering committee discussion, similar temperature data layers are available for Jimma transects. Now what we want to do is to also establish where in Jimma it is conducive for the establishment of D-beam and the parasitoids and so on. And this can be done in any other region of East Africa even, if we have the downscaled weather data sets for that region. So some potential adaptation strategy, it is we are trying to advise the farmers to reduce use of broad spectrum insecticides for the secondary pests, and also promote wild crucifers around the fields of cruciferous crops to enhance the efficacy of the parasitoids that we have released. And there is also a need to promote integrated pest management strategies for aphids and thrips, which are emerging as significant constraints to cruciferous production in this region. In this regard, I would like to say that these pests are being worked on by ICIPE in different other projects. Like I manage a project on thrips management where we have commercialized entomopathogenic fungus, which is quite effective against aphids, against thrips. And we are also developing endophytes which can induce resistance against the thrips infestation. The similar is the case with the aphids. We have some potential natural enemies, entomopathogenic fungi, which are already on pipeline for commercialization in Kenya. So our strategy is now to actually promote integrated pest management strategies for these pests to the farmers in the region. Certain technologies are very easy to adopt. For example, the aphids. The best management practice that you can inform a farmer is nursery management. If he is able to manage the pest in the nursery, he is very well able to manage the pest in the main field. So such sort of technologies are the ones that we are trying to promote to the farmers, and in this regard we have already started off in the initial farmer training in Taita Taveta in June 2014 this year. We basically sensitize the farmers on IPM strategies that are available for thrips, aphids and leaf miners in Taita Taveta, and similar exercises were also repeated in Tanzania. Yeah. So I would like to end my talk here. I acknowledge the donors and the Ministry of Foreign Affairs of Finland for the generous support they have given. I would also like to acknowledge all my partners, TPRI Tanzania, University of Nairobi, Kenya, Ministry of Agriculture in Kenya and Tanzania, and Petri Pelika, University of Helsinki, for your warm welcome, and we enjoyed your hospitality. Thank you.
Dr. Sevgan, would you have a question for Doctor at this point? I was wondering what is your feeling about the, as you said, you already have been talking with the farmers and training the farmers this June. So how was the welcoming of this this knowledge and training?
At least for Taita Taveta, it was a bit easy for us because that's a place where we have been working for more than a decade now. And farmers appreciate ICIPE's work there. There's no farmer in cruciferous farmer in Taita Taveta who doesn't know the parasitoid that we released and the impact that has caused in their transect. So in this case, when we went for the training, even it was a demand-driven training where the farmers were actually asking for management strategies for some of these emerging constraints and for some of the constraints in newly introduced crops. For example, in Taita Taveta, people are now introducing French beans, where again thrips is a serious problem. And so they wanted the management strategies, so they were welcoming the training that we gave. It will be time that when we start going back to the field and see how best these technologies are adopted and how beneficial these technologies are for the farmers. It will take some time for us also. Yeah. Sure.